So in this class, you can see it's not only a EMI class, and also this is the PjBL class. So PjBL class is like in the past, like traditional learning is professors, he or she just told what we need to know, and students memorize all the contents, and problem assigned to illustrate how to use it. But why PjBL is problem-based learning? So we need to think about what is the problems being assigned, and we have to identify what we know and then apply to solve the problem. I mean, for engineers or for researchers, we need to define our problem, and then we identify like what problem we need to solve. And we find the methodologies, we find the solutions, or we find any techniques, and then we learn and apply our knowledge. Maybe we can have more deep understanding to solve the problem. So I hope, I hope we can have more interactions. So I hope our class can achieve like problem-based learning. So first, we already mentioned you can choose either a case history or field test or any case study, but related to like shallow, deep foundation or other foundation types. It depends on like your group maths, which topic you want to. Maybe you can search some. Based on which foundation type you want to choose. Or you want to find out like different failure case, and you want to see what happened to each case. So it depends on which topic you are interested in. Yeah. And so after 2 weeks, you just present what you want to do for the term project. Yeah. So it will be like a short discussion, short introduction. So 10 minutes is enough, not more than 10 minutes, like a short presentation. And I think I will invite one professor to join us, like Professor Yang in our group, because we have to like share our ideas. Like I will also go his class to see how he teaches, like we teach this course in English, right? So sometimes professor we need to do some exchange the ideas. So after 2 weeks I will invite him to join us. Maybe he will give us some comments. When you present, maybe he also will ask you some questions.
Moderate and play. So it will be only that, and the play depends solely on the Andrei strengths. Being on the sub can use the friction and resistance. And that's all.
Okay. So you have the same conclusion? But again, I want to say that if it's clay soil, if we consider long term, we will get, if for the clay soil we still have C prime, so we still can get bearing capacity for long term. But once you finish your homework, then you will see why the clay soils we have to consider short-term conditions. Yeah, that's it for the whole idea of shale foundations. But this is just for bearing capacity. But the most important thing is the other factors we still have to consider is the settlement. So for our first week, I mentioned we also have to check the settlements. If it's a huge settlement, then even though we can have enough bearing capacity, but if the settlement is too large, then the control factors is the settlement. Yeah. So Next week, I will share how to calculate or how to read the information from the load test. Then how you decide, is it settlement control or is bearing capacity control? Yeah.
So we can get the capacity is around 126 allowable. So in this case, for example, we need to take the capacity was less than the allowable capacity. So we assume 100. So based on the y-axis and we can get the settlement is around 4.7 millimeter. And in this case, we also have the allowable settlement is around the requirement is 6 millimeter, and from the x-axis, and then we can get the lot is around 140 or 150 lot. So we can compare the allowable less than the 140 or 150. So I think the bar is governed by the capacity. That is
Please. Everyone can try to explain again by yourself, then you will have deeper knowledge or you really digest your knowledge and how to explain to everyone. Just train yourself how you explain things to everyone. Just try.
So we did a similar thing as the previous ones. And in this case, we divided the ultimate load by 3, so we got 84. And then, using the free curves, we obtain a settlement for the working load between 2 and 3 millimeters. So honestly, we selected the lowest settlement, allowable settlement, which was just 6 millimeters. So we concluded that the file will be governed by capacity.
This is a candidate and fix it. Then solve the problem using finite element methods. And we divide this being into 4 elements. Then how we determine we will explain why we have to use constitutive model, and we have to do some force balance, and we have to decide the local stiffness and global stiffness thing. Also, we have to know the boundary conditions, then we can solve everything. We can get the knot deformation, and also can solve the force for each point by using this case. So you can preview these slides. So you can see the concept of finite elements. We cut the beam into several pieces.
You can see the lambda is not the lambda is the characteristic parameter, and it's not the mathematical consistent, and this also represents the relative stiffness between the soil and the beam. And when the lambda is low, when the lambda is high, it means the soil stiffness is high. So it means the soil is stiffer than the beam. And when the lambda is low, it means the EI high, and EI is greater than the beam. So it means the beam will be stiffer than the soil. And we move on to the detail.
Great, so good morning everyone. My name is Jose. I'm not sure remember, but I'm gonna give a brief explanation about the SPT test. since it was a topic that was mentioned last class, and I hope it can give you a better understanding. Okay, so the SPT stands for the Standard Penetration Test, as it was mentioned before last class, and it's a very basic test that is performed on site. Okay, so here we have an illustration of what the mechanism looks like. The mechanism comes with three main components, which are the hammer, which counts with 63.5 kilograms. This hammer is dropped from a height of 760 millimeters, and also a very important part of the mechanism is the steel spoon sampler, which is 50 millimeters in diameter. Okay, so how does this work? The hammer is dropped from a height of, as I mentioned before, 760 millimeters until it's reached a certain depth. This number of blows that is required for the hammer to reach the certain number of depth, the certain depth, is recorded and is called the number of blows. The depth that we want to achieve with this test is three consecutive measurements of 150 millimeters each. And the number of blows that it takes to achieve those three consecutive 100 millimeters of depth is recorded. And that is the number of blows. And now, why is it so important? Because with the number of blows, we can obtain a lot of information from the soil. For example, if the number of blows of the M value, which is its real name, is very small, like for example from 0 to 4, the soil is too soft or too loose, like maybe sand or soft clay. If it's too high, like above 30, the soil will be too hard, like decomposed rock or maybe stiff clay. And it's also essential for calculating the bearing capacity of the soil, and it helps predict how much a structure will sink over time. And also, as I mentioned before, with this part of the mechanism, which is the spill spoon sampler, the test is able to collect soil samples to further analyze it on labs, and it also gives visual information to the engineers.
First, we know that what the deformation. So as we know that the deformation is the formation which is used to transfer the heavy structural load and load of the building deep into the ground or hard strata like rock layers, and it is used where the top surface soil is weak and which is unable to carry the load, and sometimes it is used where the water level is high and or nearby some river sites where scour can happen, and sometimes it is used to reduce the settlement also. And there are some common types of pile, board pile and iron pile caissons and pallets also. So in India, the deformation is used in bridges, metros, and skyscrapers, buildings, high-rise and high-speed rail has been made foundation of critical engineering disciplines. So this study focused on real-world case studies involving pile foundation in landmark Indian structures. Because we have three case studies. First is Cable State Bridge in Mumbai. Mumbai is situated in their coastal areas where the soil is behind soft clay and loose soil. So
Research. Well, this research was performed in Sangatta, which is located in the East Kutai Regency of Indonesia. Specifically, as my partner mentioned, in the Sangatta Lama Suspension Bridge construction site. In this construction site, the research was performed in the borehole point DH2, where the soil characteristic or the soil profile around this point was the one of non-cohesive soils, specifically with layers of sandy loam and silty clay. In this point was where the data was obtained to perform the research, and the concrete pre-stressed bonds were tested.
also an additional case study. The project involved a highway and very close to the 10-story building. And the problem here is that the urban construction, we are talking here about clay layers and silty sand. And the thing here is that the bridge foundation triggers groundwater flooding at the base and causing the foundation of the building to tilt and to crack. Here we can see some pictures. And one of the solutions of the paper using the grouting. The grouting is a technique that involves a mix of cement, water, and some additives. And my classmate already explained some specific examples, but in this case, it's used to enhance the strength property of the soil in order to avoid the tilting, and in the meantime, add some piles and below the foundation to enhance the stability.
I just show we have some temporary walls, or like we have fence and doors, or actually we have different gates, and also they also prepare a space for the steps to have some progress. So this slide is, as I mentioned, very important. We have to try to know what we have for our soil products and how we do site characterization to well prepare this simplified soil stratification for design. So you can see we have SPT and value, and also we have some of water contents and some strength parameters like pitch angle and cohesion. And also we have those mass modules and H is for the strength of our substrate conditions. These are for foundations. And some parameters are just describe the soil properties. But very important thing here is we have above is a field layer, and we have mostly clay. Also we have sandstone. And both for the level wall and every tile, they should be we have to construct these two into the sandstone, the bedrock.